Hello everyone and welcome to Fadi's approach to project network example number 2. I strongly recommend that you watch example number 1 first and familiarize yourself with how I do the project network calculations, and then come for this example because this example is going to be much more complicated. So with this example, this time, not only that we have more tasks, but there are going to be lots of parallel activities. And the first thing you do when you are given the table that you need to create your project network from is to familiarize yourself with what you have there. So we have the first column, which shows the sequence of the activities. So this is A, B, C, D. They're numbered as such. Sometimes they are numbered numerically. Then you have the activities themselves. So again, familiarize yourself with them, even though you will not need them so much when you draw the diagram. So receive directive, planning, analysis, design, develop the first prototype, collect feedback, develop the second prototype, collect feedback, complete the product design, manufacture sample, testing, and approval. So this is clearly producing something of a machinery. And you can see the duration there. Then we have the predecessors. So of course, the first one, receiving directive, will have no predecessor. It's the first activity. But you can see immediately that planning and analysis are going to be parallel, because as soon as you finish receiving the directive and you understand it, you can start planning and analysis at the same time. If you look at the next activity, design can only start when planning and analysis are finished. So maybe planning will take less time, only 3 days. We can't start until analysis finishes. So we're going to have to wait 6 days for the design to start. And that's why it says it has to wait for B and C to finish, and so on and so forth. So I would recommend you at this point to pause the video and start drawing it yourself, because only with practice you can see whether you understand project network or not, and then come back and see whether you did it correctly. So if you're ready, let's get started. So the objective, of course, is to create the project network itself. It's going to be looking something similar to this. And the objective is to find the total duration of the project and something we call the critical path. The critical path, outlined in red here, indicates those activities that if they're even delayed by 1 day, the whole project will be delayed by 1 day. And we want to avoid that as much as possible, any delays. The ones that are not in the critical path, it means we have some flexibility. If they're late 1 or 2 days, the number of the delay that we can still manage with will be indicated in something called slack. All right, so let's start with the first reminder of how we do our each activity. Now, there's different approaches. Some people use circles, some people draw it on the line. We're using the box because it is the most intuitive way of presenting an activity. These are different activities that we need to create. So in the middle, we put the activity description. It is actually optional. Many people don't, because to make it just easier and faster to draw the diagram. So in exams and stuff, check with your tutor whether they want you to write the activity in the description there. But what you can't miss is indicating the duration of the activity and the number of the activity. On the top, you put the letter A, B, C, D, and on the bottom, you actually indicate how long this activity needs. This should be the easy part of the diagram. Now we get to the calculational part, and this is where people get a little bit tricky. But all you need to know is these basic facts. On the front there, we put the earliest possible start of an activity. For instance, the first one is 0 days because it's the first activity. That's the earliest start. But we just saw a second ago that design can't start until both B and C are completed. So they have to wait for the other ones, and then you can indicate that in the earliest possible start. In the calculation, it's just straightforward calculation. You don't have to worry what they actually mean sometimes. So earliest start, earliest finish. What's the earliest possible time to finish this project? Latest possible time to start and latest possible time to finish. Now, these would have been explained to you in the classes as what they mean. What's the earliest start? What's the latest possible start that would not delay the project? The earliest time we can finish the project, whereas the latest time we can finish that activity, without any delays. Familiarize yourself with these, but really when it comes to calculation, it's just visual way of doing it, and that's my approach. Many books and lectures, they go into formulas and calculations that sometimes get a little bit tedious and confusing. I'm more of a visual person. I like to visualize what I need to do, and somehow it's easier than writing a formula. It's not everyone's cup of tea, but I call it my approach, and it's what makes it easy. So let's start with the steps of drawing your project networks. The first two steps are very easy. The first one is drawing the sequence. So you look at every activity, you label it, and you say, what is before it? So we start with the first one. It's going to be activity A, followed by activity B. Now we look at the table on the top there, and you're going to say that B has to wait for A to start, to finish. So B has to wait for activity A to finish to start. So therefore you have that arrow there. Also C has to wait for activity A to finish. So that's getting the directives, and then you can do the analysis and the planning. So this is the bit where we have parallel activities. If you remember, also D had to wait for B and C to finish, and that's also indicated in the table over there. Yeah, so it's indicated in the table over there. D has to wait for B and C. I'll put the arrows there. And then we follow suit. So you can see that E needs B. So you might have put it initially here, but you realize it needs B, so you move it up and you connect it. You notice that F will need E. You'll find that G needs E, so you move it a little bit. H will need G. I will need F. J goes back a little bit and needs D to start. K will need, let me just move it a little bit so that I'm not in the diagram. So K will need H and J. And then finally, I know this is behind my head, L will need I and K. And it's normal that sometimes when you first draw the diagram, it'll look a little bit messy. So you take your time and reposition it so it looks better. And that's why when you do it digitally on a Word or PowerPoint, it gives you more flexibility than when you do it on a paper drawing. So now that we've tidied up the drawing of the sequence, the next activity is to fill in the duration. And that should be straightforward. Activity A needs 1 day, activity B needs 3 days, activity C needs 6 days. So you just add them. So this is activity A, 1 day, B, 3 days, C, 6 days, D, 6 days, E, 2 days, F, 3 days, G, 3 days, H, 4 days, I, 5 days, J, 4 days, K, 2 days, and finally activity L, 3 days. Should be straightforward, but here's the issue. If you make any mistake in the first 2 steps, and that's why you should take your time. I know it's easy, but if you make any mistakes, the whole calculation will be messed up and you lose most of the grade. So do take your time with the first 2 steps. At least you'll get a proportion of the grade that is considerably easy. The next step will start our calculation. Now, if you've seen example number 1, you see that it works visually. We're going forward, so that's from left to right, yeah? So left to right. And we do that V shape. So this is the V shape, yeah? We go from the top left to the top right, okay? And you do it like that. And we always add, and where we have an option, we look for the bigger number. So let's do it together and see how it works. So now activity A is the starting point, and it's going to have to be day 0. Now to add the numbers, 0 plus 1 becomes 1. And this is the V shape I was telling you about. So this is the V shape. It's 0 plus 1, which is the duration of activity A, will finish on day 1. Then we go for activity B and C. They have to wait until activity A finishes, so they will get 1, 1 each. And then you add them. So activity, for instance, B, 1 plus 3 is 4. Activity C, 1 plus 6 is 7. Now here we come for the first opportunity where we have a choice. D needs to decide whether it's going to wait for B or C to start. And we said it has to wait until the last one to finish it. It needs both of them to be completed. And therefore, the logic is that you wait for the bigger number. So which one is bigger, 4 or 7? You can see this is the bigger number wins. And in this case is 7. So then you do the calculation. 7 plus 6 is 13. You pass it on onwards. But before we go to that as well, we look at activity E if we're going alphabetically, but there's actually no necessary sequence. I could have gone to J if I wanted, but because D is ready, but we'll go by alphabetical order. So A, B, C, D, E. E has to wait for B to finish, so therefore it gets 4, the top number there. 4 plus 2 is 6. We could go to F because we're still going alphabetically. It takes the number 6. 6 plus 3 is 9. And then we go to G, which waits for the letters E to finish, so that takes 6. 6 plus 3 also is 9. H takes the 9 from G because it has to wait for it to finish, becomes 13. 9 plus 4 is 13. I takes the 9 from the letter F, activity F, so 9 plus 5 is 14. And now we go to J, because it's alphabetically. J had to wait for activity D to finish, so it takes 13. 13 plus 4 is 17. We have K, and again, we have two choices with K. So take a moment and tell me, which one are we going to take, the J or the H? Again, the bigger number wins. Is it going to take 17 or 13? It's going to take, of course, 17. 17 plus 2 is 19. And we get to L again. L has a choice between I and K. So again, it's going to go with the bigger number. And the bigger number is going to be 19. 19 plus 3 is 22. So the total duration of the project is 22. And sometimes students make that mistake in the exam or assignment, where you ask, what is the total duration of the project? And they add up the table that we had at the beginning. If you did add up the table in the beginning, it's actually 50 days. And that's because in this case, we have too many parallel activities. In fact, the project can be done in as little as 22 days. And that is the power of project network calculation. It gives us, if we have all good resources and we can run several activity parallel, we can finish it in less than half the time. So this concludes, in a way, our forward path calculation, because now we know the total duration of the project is 22 days. The next stage is to do the backward path calculation. The backward path calculation, in this case, we'll have to start with moving the 22 from the top to the bottom. And this time, we don't have V-shape, we have a straight line. So this is a straight line like this. And we subtract. And when we have choice, the smaller number wins. So it's basically opposite to the backward path calculation. We go in a straight line, it's a minus, and the smaller number wins. So let's get started with this. 22 minus 3 is 19. And 19 is passed on to I and K because they're waiting for this number to come through. We go with K. K, 19 minus 2 is 7. I, 19 minus 5 is 14. We go to J, which takes the 17 from K. So 17 minus 4 is 13. We go to H, which also gets the number from K. So 17 minus 4 is 13. We go to G, which takes the number 13. Remember, it's the latest possible start, and it takes it at 13. 13 minus 3 is 10. We go to F, which takes 14 from I, minus 3 is 11. Now here's the first time we have a choice. E gets two inputs really from F and G. And the rule is we have to take the smaller number. Now don't make mistake, it's the bottom part of the box we need to look at. So we have a choice between 11 and 10. So which one will be the smaller number? Yeah, so this we're looking for the smaller number win. It's going to be 10. 10 minus 2, there is 8. We go to the letter D because we're doing it alphabetically. It's getting the number 13. 13 minus 6 is 7. And then we pass it to C. 7 minus 6 is 1. We go to the letter B, and again, we have a choice. We have a choice between 8 and 7 in this case. Again, we're looking for the smaller number. Between 7 and 8, what will be the smaller number? The smaller number will be 7. 7 minus 3 is 4. Again, we have another choice with activity A. Between 1 and 4, we're going for the smaller number. It's going to be 1. 1 minus 1 is 0. And here's a very important end calculation we do when we do the backward path calculation. If we have zeros at the very front for activity, the first activity, it means we did our calculation very well. So you can congratulate yourself. You have done the forward and the backward calculation. These are the trickiest ones. And it also validates that when you did the drawing and the sequence, you did it correctly. And that's why the numbers added up and you got 0 zeros. So we've completed our backward path correctly when you see the zeros there. Now we calculate the slack. The slack is how much free time do we have that would not delay the overall project. So where we have any number other than 0, then we can say that we have some slack. Where we have 0, it means any delay on that activity can delay the whole project beyond the 22 days that we have available. So let's take a look at the first one. 0 minus 0 is going to be 0. Activity B, 4 minus 1 is 3. So we've discovered our first slack. Activity B, the planning, can take 3 days more, and it's not going to delay everything because anyway we're going to be waiting for analysis to finish. That's the logic behind it. And when you look actually on analysis, we can't be delayed at all because it's going to take the full 6 days, and we can't take any longer than that, otherwise the whole project will be delayed. We go for activity D, the same thing. We can't have any delays, it's 0. Activity E has a slack of 4. Activity F, again, 11 minus 6 is 5. Activity G, 10 minus 6 is 4. Activity H, 13 minus 9 is 4. Activity I, 14 minus 9 is 5. Activity J, 13 minus 13 is 0. K, 17 minus 17 is 0. And L, 19 minus 19 is 0. And we have now completed all the calculations that we need to do for the project network. So our next bit is to identify the critical path. As I said earlier, the critical path is those activities that usually have to be in sequence, otherwise you must have done a mistake in your calculation, that if any delay on that sequence happens, the whole project will be delayed. And therefore, as a project manager, you focus all your resources to make sure these activities are well resourced and they finish on time. And in some cases, if you invest a little bit more money, you probably could speed up things if you speed up these activities. So that's another topic. We'll talk about it another time. But now we're going to focus on those activities that have 0 slack. And we're going to highlight them in red. So we start with the first one. It always tends to be the first one as a critical path, and that's A. Now between B and C, which one is going to be critical? C. It goes to D, that's critical. We go then, we see E, F, G, I, H, they all have slack, so they're not critical. The one that's going to be next critical is J. After that is K, and after that is L. So our critical path is A, C, D, J, K, and L. And that's really the end of the project network. Now, what I would advise you is familiarize yourself with how I visually try to draw the formulas. And what you could do in the exam is try to put them together, draw them before you get started, so you kind of visualize what you have to do as opposed to writing the formula. But remember the sequence as well. First, step 1, draw the sequence. Step 2, fill in the duration. These two should be very easy, but please pay attention. I've seen students in the past who just make a small mistake in one of them and it messes up everything. And you really don't want to do that. You lose a lot of the grade and it's not a difficult part. Then you do the forward path calculation. And again, you visualize it. It's a V shape. You add the numbers and you go with a bigger number when you have a choice. At the end of it, you get the total duration of the project. You do the backward path calculation. Again, it's a simple arrow going back on the bottom of the boxes. It's subtraction, and where you have a choice, you go with the smaller number. The aim at the end to make sure is the first activity has 0 on the top and the bottom, which indicates your calculations were correct. And then you calculate the slack, which is the bottom number minus the upper number. And this helps you identify those activities that have 0 in there as slack, and these become the critical path. Well, I hope my approach has helped you understand project network, and now you feel more confident to use that in your future calculations.